from Tomcat Gas Training, and welcome to this video all about these. Now this is a flueless space heater. So what does that mean then? Well, basically it's a gas fire that doesn't require a flue or a chimney. Now the reason why I want to do this video is because this kind of appliance concerns me a lot. Because one, when we go out doing portfolio work with trainees and we come across these fires, most of them are installed incorrectly. And then the second thing is when guys come in for reassessment, so when gas engineers come back to us every 5 years to redo their tests, they all say the same thing: don't touch flueless space heaters. So basically what I want to do with this video is, one, put engineers' minds at rest to say if they're installed correctly, if they're serviced correctly on a regular basis as well, then they are completely safe. So as usual, let's stop waffling and let's get on with this video and find out exactly what flueless space heaters are all about. Now before we get cracking, just let's have a disclaimer. Remember, you have to be gas safe registered to install a gas appliance. Okay? You have to be gas safe registered and be qualified on fires to be able to install these. You also need a flue gas analyzer and know how to use a flue gas analyzer to be able to work on these appliances. So that's the disclaimer, so now we can get on with it. Let's start by having a look at the advantages and disadvantages of flueless space heaters. So the first thing is they're cheaper to run than an electric fire. They're about 9p an hour for a 2 kilowatt fire. They are 100% efficient like a electric fire is, because the products of combustion are coming into the room. So they are a flueless appliance, pretty much like a cooker is a flueless appliance. So there's no need for a chimney or a flue. So unlike a traditional open flued fire, that would require a flue or a chimney. Number three, easier and cheaper to install. So they're easier and cheaper to install because you don't need a flue or a chimney. You can have them wall mounted. They can be built into a fireplace opening, pretty much like a traditional fire, or you can even have stove type ones as well. So they come in loads of different styles. All of them come with an atmospheric sensing device or a vitiation sensing device. So they all come with a safety device, so if the room gets vitiated, and vitiated means lack of air, then they will knock off. Okay? As long as they're installed correctly and serviced on a regular basis. All must be made to the European standards and the British standards and the regulations. So they're all highly regulated and tested. And the location can be on, obviously inside a property, not outside. So they can all be on an external wall or an internal wall. They can even be installed low down or high up. There's no restrictions because there's no flue. Well, technically they say there's no restrictions, but you must always follow the manufacturer's instructions when you're installing any kind of gas appliance. So they're kind of what the manufacturers say are the advantages of a flueless space heater. So let's look at the disadvantages. Let's have a look at these disadvantages then. So number one, it requires an air vent to outside air of at least 100 centimetres squared. Now because this is a flueless space heater, it requires ventilation. At least 100 centimetres squared. So I'm going to look at ventilation in depth a bit later on, but they require a minimum of 100 centimetres squared. That's up to 2.7 kilowatts. If it's over 2.7 kilowatts, we need an additional 55 centimetres squared of free air per kilowatt over the 2.7 if it's installed in a living room. But again, we'll look at that a bit closer later. The room requires an openable window. Again, because this is a flueless appliance, the building regs say flueless appliances require an openable window. And the manufacturers say this is because really there's no thermostat on there, so there's no way of regulating the heat, so if the room gets too hot you can open the window. There needs to be another source of heat in the room, so this fire cannot be the primary source of heat. You'll require a radiator. If you haven't got a radiator, you cannot have a flueless space heater. They require a catalytic converter. Technically not all of them, they say. I don't think I've ever seen a flueless space heater without a catalytic converter, but I believe there are some very, very low kilowatt ones out there which don't need them. And the only ones I can think of are the little paraffin ones what you can get, which is from America. Anyway, I haven't seen one without a catalytic converter in the UK, but I have seen them in America. There needs to be a room volume of at least 30 metres cubed. Now, like I say, when we look at the ventilation, I'll look at this again a little bit closer, because the manufacturers will say 30, some say 40, some say 50, some say 60. But we'll have a look at that in a little while. The air vent needs to be 1 metre away. Now this 100 centimetres squared up to 2.7 kilowatts, they say, needs to be at least 1 metre away from the appliance, because if it isn't, the ASD or the VSD could stay on. Now some of the manufacturer's instructions say 500 away, but this has been changed in the regulations to at least 1 metre away because of this scenario they're finding. The fires are staying on, they're not knocking off, and they're vitiating the room and could kill people. So make sure this vent is at least 1 metre away. And if you go to an old installed fire and it isn't 1 metre away, this makes the appliance at risk. Okay, and will need to be moved. If the glass front is cracked or broken, you cannot use the fire. This is because this glass front plays a massive part in the combustion process, because what it does is it funnels the products of combustion through the catalytic converter. So if that glass is broken or missing or cracked, then the products of combustion can come out through the front. But some of the fires have a gap at the bottom of the glass and it's not sealed, because that's where the air comes in to help the catalytic converter draw through the products of combustion. When I strip the fire in there and we'll have a look at it, I'll explain that in a little bit more depth. So that is the disadvantages of what the manufacturers say for these flueless space heaters. Now, a couple of things I just want to clear up on the installation. First one is, when you install the fire or the flueless space heater in the position of an old open flued fire, you can't have the old fire opening open at the back, because what that will do is that will be kind of the same as the vent being too close to the fire. It will keep the ASD on. So that has to be completely sealed, and that includes vents what are put into chimney openings to stop condensation. That's the first one. Now the other thing is, these fires, flueless space heaters, cannot be installed in bathrooms or shower rooms because of the damp atmosphere. And then this is the one I don't get. Some manufacturers say you cannot install them in bedrooms. Other manufacturers say you can install them in bedrooms as long as you've got a CO alarm or a carbon monoxide alarm. I don't think I would be installing one in a bedroom, because that's where you go to sleep. So what if you go to sleep and leave it on? Mind you, anyway. Yeah, read the manufacturer's instructions on the installation of a flueless space heater in a bedroom. I personally would never fit one in there, and I would always advise a customer, think of something else. Why would you need a fire in your bedroom? You want it cold, not warm. Anyway, that's a few things on the installation. Now you can see I've stripped it down. So I've taken the outer cover off and the glass. So like I've just been saying, this is the important thing. Now if I flick it over, you can see there is a seal down the sides, across the top, but there isn't across the bottom. Because like I was saying, the air for combustion has to come in through the bottom, up through here, and the catalytic converter is here, just under here. So when this glass goes back where it should do, it allows the air to come through the front here to keep the glass clear, but the air comes in through the bottom here, comes through here, and then is scrubbed by the catalytic converter. So what do these catalytic converters do? Well, basically they take the carbon monoxide, the CO, and turn it to carbon dioxide by adding oxygen basically and scrubbing. They also say these catalytic converters are great for people who suffer with allergies, and they will clear the air of pollen and dust mite and stuff like that. That's one of the pros they say for a catalytic converter. How true that is, I don't know, because I don't have one in the house and I really do suffer with allergies. But that's what they're supposed to do, these catalytic converters. They take the CO and turn it to CO2. Now, I'm going to look at the flue gas analyzer test later, okay? So we'll talk about what results we should be getting when we're doing the test with the flue gas analyzer later. But first of all, we're going to look at the burner and we're going to look at the controls. First thing I'm going to do is I'm going to test the safety device here. So first I need to light it. So I've lit the pilot, hold it for a few seconds, and then I can let go. Right, so the first test I'm going to do is I'm going to blow the pilot light out. I'm going to time how long it takes to click. So let me get my watch ready. About 16 seconds, so it has 30 seconds to knock out. So that's the first thing we're going to do. I'm now going to relight it. So what I've done is I've removed the lint arrestor from around the pilot assembly, and I know exactly where the hole is for the pilot assembly here, and I'm going to check now the ASD. So I'm just going to put my finger in here, if I can get my hand in, and I'm going to block off the ASD, and again it should knock off. So you can see the incomplete combustion there. So this is what would happen if the air got vitiated. And there you go, VSD knocked off. I don't know how long that was because my watch is on my right hand and I can only get my right hand in here. So it was well within 60 seconds, but there you go. So that's checking. I need to put the lint arrestor back now. But that's checking the pilot light. Okay, so that's checking the thermoelectric device and it's checking the ASD. Another way guys do it is, which I don't really get, but there you go. Because they will get the screwdriver and they will block off the port going to the thermocouple. And what that does is it shows them also that the gas is knocked out. So that's another way of doing it. I don't do it that way. I'll blow it out because you can hear the pilot and you can hear the gas coming out. So that's how you check the safety devices on this fire. So if you are having your fire serviced, you're a customer, the gas engineer will need to check the safety devices because they are incredibly important. So we've done all the testing of the safety devices. Let's turn the burner on. Remember, the glass has been removed. I've removed the glass for now, but you can actually see the burner gives off this yellow floppy flame, as if it's giving off carbon monoxide. Now that's how it's supposed to be. Okay, that's how they've designed this fire, to give you this warm glow look. And now the glass on the front will take up the products of combustion and through the catalytic converter. Other tests we would have to do at this stage now, obviously once the glass is back, we would do our burner pressure from here. Okay, if we had an inlet pressure test point, we would do that here, which we haven't got. And then we would also have to go and gas rate. Now, this fire is 2 kilowatts. It says on the data badge down here that its input is 2 kilowatts. So when we gas rate this, we have to be within this given percentage, which there's no such thing. We need to get as close as we can to this 2 kilowatts, so we know the fire is safe. Okay, so we would do burner pressure, which is 17.8 hot and 17.5 cold. Then we would gas rate, which we need to get 2 kilowatts, and then the final test we would do flue gas analysing. So let's have a look at the most important part of this testing. Let's see what products of combustion we are getting out of this flueless space heater. Now, flue gas analysing this now, how the manufacturer tells us how to do it. So it says place a probe on the top here like that, a 5-hole probe. And it says make it run for at least 15 minutes before you take your readings, and no longer than 30 minutes. So we have at the moment, because it has been running about 15 minutes, we have a CO of 18, a CO2 of 3.3, and a ratio of 0.0006. Now in the manufacturer's instructions it says the ratio has to be lower than 0.0015. Okay, which we are. We're lower than that. But it doesn't give us a CO and it doesn't give us a CO2. For the fire coming out the fire, it just says to test the room and make sure the room is less than 9 parts per million of CO. This has now got a CO, don't know whether you can see that now, that's what it's reading now, which is a CO of 19, a CO2 of 3.4 and a ratio of 0.0006. So that's what it's giving us. Now this catalytic converter is supposed to turn this CO into CO2. So normally we get a low CO and a moderate CO2 reading, but my CO readings are climbing up on here. So if I did leave this for quite a long time, it would be interesting to see what's happening, because there's no permanent ventilation for this appliance. So this CO will keep rising and rising and rising because I've closed all the windows and doors. Now these vents don't go anywhere, they're dummy, so there's no vents, there's no fresh air coming into this room. So because there's no fresh air coming into this room will get vitiated. So I've left this running for 15 minutes with all the windows and doors closed to this room, and our CO levels coming from this fire will start to rise. So this shows you how important the ventilation is for this appliance. So let's have a look at the ventilation requirements for flueless space heaters, and let's try and sort out exactly what they require. So let's have a look at the ventilation requirements for these flueless space heaters. So we've got appliance type, maximum rated input in net, room volume, vent size, and whether we need an openable window or not. Same as what you would do for a cooker. Remember, it's a flueless appliance. So we've got a space heated in a room, so that's a living room, dining room, and we've got our maximum rated input in net kilowatts of 45 watts per meters cubed. I'll go through that after this. It says room volume meters cubed with a dash in it because we're looking at the 45 watts per meters cubed. And then it says the vent size. We need 100 centimeters squared plus 55 centimetres squared for every kilowatt over 2.7 kilowatts net, and an openable window. I'll go through all this 45 watts in a minute. So space heater in an internal space of 90 watts per metres cubed. Again, the room volume is the 90 watts per metres cubed. We'll have a look at that in a minute. And it then says 100 centimetres squared plus 27.5 centimetres squared for every kilowatt over 5.4 kilowatts net with an openable window. So we'll look at that. And then we've got a space heater conforming to BS EN 499 2002. What the hell's that? Well, it's an LPG fire. Okay, and that's one stored in a room. We've then got up to 50 watts per metres cubed, but the room volume has to be greater than 15 metres cubed, and then it's 25 centimetres squared per kilowatt with a minimum of 50 centimetres squared at high and low level with an openable window. And again, space heaters to BS EN 499 2002 is again LPG, and again it's to an internal space. This time it's 100 watts per metres cubed with a room volume has to be greater than 15 metres cubed, and again it's a 25 centimetres squared per kilowatt with a minimum of 50 centimetres squared at high and low level, and an openable window. So that's what we need to be working to for the ventilation. Now, before we move on to how do we do this bit here, the 45 watts per metres cubed, the ventilation is incredibly important. Now, if you're a gas engineer, first of all, manufacturers say the best way of doing this is 50-50 split. So if you need 100 centimetres squared, get two vents, 50 centimetres squared each, and put them high level and low level. Okay, now then, for customers, you do not block these vents, okay? Even when you're not using the fire. Never ever block a permanent vent for an open flued or a flueless gas appliance. You might not wake up, okay? So please, if you're a customer, never block an air vent up, even when you're not using the fire. As an installer, if you think about where you're putting these vents so it's not blowing cold air across the customer, then they technically won't be bothered at blocking the vents. What the manufacturers do say about the ventilation for these flueless space heaters is, one, it can aid convection and distributing the heat around the property. So if you're using a flueless space heater in a living room, leave the living room door open because it will then go around the property. So let's have a look and find out exactly what we mean by 45 watts per metres cubed. So this is the example for 45 watts per metres cubed. Now it says it needs to be the net figure, but we'll take the fire we've just been working on, which was 2 kilowatts gross. So how do we turn gross to net for natural gas? Well, we need to divide by 1.11. So if we do 2 divided by 1.11, we've got 1.8 kilowatts net. Now then, the manufacturer's instructions for this fire says it cannot be installed in a room with a volume of less than 30 metres cubed. Okay, so that's basically it, because the manufacturer tells you what size the minimum room is. But if you do not have the manufacturer's instructions, what it says is this. If we take this 1.8 and times it by 22.22, that will give you your minimum room volume you can install that appliance in. Comes out at 40 metres cubed for the room volume, but the manufacturer told us 30. So it's important, if you are a customer, to keep these manufacturer's instructions, because the engineer, if he doesn't have the instructions, could be saying your room volume is too small. Okay? Now, if we take this 45 watts per metres cubed and times it by the room volume of 30, it comes out at 1,350 watts we're allowed in a 30 meters cubed. And if we do 1,350 divided by 1,000, because there are 1,000 watts in a kilowatt, comes out at 1.35 kilowatts, but our fire is 1.8. But again, the manufacturer says it can go in a room greater than 30 meters cubed. And the other way of doing it, 45 times 40, okay, because that's basically what we've got here, 1,800 watts or 1.8 kilowatts. So if you haven't got the manufacturer's instructions, you follow Arthur timesing it by 22.2. I'll do the 45 watts by the room volume, and that'll tell you what size you can have in the room, or what size appliance you can have in the room. So I hope that's not too confusing for you. Go off the manufacturers, whatever the manufacturer says. If they say it can go in a 30 meter cube, you can do, but if you don't have the manufacturer's instructions, then you've got to follow the scenario here, the 45 watts per meters cubed. So that's exactly what this 45 watts per meters cubed means, and you would do the same for 90 watts per meters cubed. But remember, if you've got an appliance over 2.7 kilowatts, then you'll require another 55 centimeters squared per kilowatt over the 2.7. Okay, so just bear that in mind too. Now let's finish off by talking about the life of this fire. Now, according to the manufacturers of this fire, the catalytic converter within the heater itself will last for about 11,000 hours, which is about 10 years they say. But some manufacturers will say they will last between 27 and 30 years with normal use. Because remember, we're not going to use them all year round. And what's the maximum length of time you're going to have them on? An hour or so? So they will last quite a long time, as long as they're serviced and checked every year. Now, that was our video on why gas engineers are scared to death of flueless space heaters. So if you've liked this video, why don't you give me that thumbs up or leave a constructive comment down below. If you've not subscribed to our channel, then please subscribe, and don't forget to hit that notification bell, because YouTube will tell you when we upload videos, which is mainly on Mondays and Wednesdays. All I've got left to say is thanks for listening, thanks for watching, and after this video, hopefully now we're fully coerced with flueless space heaters. Cheers guys!